All right, lesson 7, drawing parallelograms. So what you're going to need is plain paper again, a protractor, a ruler, and you have to have a set square, either the 30, 60, 90 degree or the 45, 45, 90 degree. Or you can make your own out of thick paper or cardstock or a old folder that you have. You could have also gotten this in your geometry kit, so if you have that in your geometry kit, you can use, again, either one of the set squares. If you have to make a set square, again with thick paper, whether it be cardstock or a folder or if need be construction paper, these are the directions to make a set square. It's almost kind of like making a hat or a boat or a paper airplane. But you would have to fold over the one corner so that the edges match up, and then you would cut off the one edge, and as it is folded, you might, to make it a little bit stronger, you could either tape the edges, and we would check to see if the lines are parallel using your set square. So we're going to do that. We're going to check to see if lines are parallel using our set square or your homemade set square. All right, so let's go ahead and do a parallel line test. And I'll go ahead and demonstrate, but this is kind of how you would use a set square. All right, so let's see if two lines are parallel. If we have a set square, and again you can use either one, this is what a set square is if you got the geometry kit. What you would do is you would place the edge, one of the legs, not the hypotenuse, on the parallel line so that it matches up. Then once you have done that, you're going to use your ruler to put that against the other leg, and then what you do is you slide the set square down and you would check to see if the next line is parallel. In this case, these two lines, even though they look like they might be parallel, they are clearly not parallel because the set square is not lined up with the bottom line. Or vice versa, if I set my set square to the bottom line and then move up, notice how this is not going to line up either. So in this case, these two lines, even though they might look parallel, and I would kind of exaggerate it a little bit so you could see the difference, these two lines would not be parallel. So what would parallel lines look like? Well, let's move over to this set and try our line test. So again, using our set square, and again, it doesn't really matter which direction you have it. We can do it the other way as long as you are not using the hypotenuse. The hypotenuse being the long side. This is not how we're going to do it. So we have to use, because what we need is the 90-degree angle. So setting up our set square along our parallel line, we use our ruler against the other leg, and then as we slide, it should match up with the second line. That way we know we have parallel lines, plus we know our set square is correct, and it is a true set square. All right, so once we've done that, let's go ahead and practice using our set square to draw parallel lines. So on your separate sheet of paper, let's go ahead and draw parallel lines. So using your ruler at any angle you would like to, go ahead and draw about a 5 centimeter parallel or 5 centimeter line. Okay, so here is our line. And we're going to call it line AB. So the beginning point is A, the ending point is B. So now we're going to go ahead and draw a point somewhere that is not on line AB. And you can put it anywhere below it. So let's go ahead and just make a point and call it C. So how am I going to make sure that if I want to draw a parallel line through C, how do I make sure that the line I draw is parallel? Well, again, we use our set square. So lining up our set square along our line AB, or line segment AB, and then using our ruler against the other leg, we go ahead and we slide our set square down until it crosses through point C. And now we can use our set square. Let me try that again. If you end up moving it, just reset and try it again. So moving or sliding down, I'm going through point C, and I can't draw the whole entire line, but I can at least draw part of my line that goes through C. And then if I need to make my line bigger, I would go ahead and just use my ruler or straight edge and just continue my line to make it bigger. So that is how you, for sure, draw parallel lines if you need it to go through a particular point. All right, so you're going to need this information and using your set square to complete the rest of these exercises in drawing parallelograms. All right, so let's put that aside, and you're probably going to need to pause the video, but we need to do some review on common triangle and quadrilateral names. So go ahead and copy these down in your math journal. We have acute equilateral triangle, which is a three-sided, three-angled shape with equal acute angles, which are at 60 degrees, and equal length sides. Then we have the acute isosceles triangle, a three-sided, three-angled shape with two equal acute angles and an additional acute angle, and two equal length sides and an additional side. Notice how we designate the congruent sides or equal sides by using the tick marks here. And up here, to show that all the angles are the same, we have one arc mark here and one tick mark for each side. Then we have the acute scaling triangle, a three-sided, three-angled shape with no equal acute angles and no equal length sides. So notice how the arc marks are all different to indicate that these are all different, and the side lengths are all different. Even though you might think that these two are the same, the fact that they've put the tick marks here indicate that they are all different. All right, sketch out these. We have the obtuse equilateral triangle, a three-sided, three-angled shape with two equal acute angles and one obtuse angle, and two equal length sides and one additional side. So here is our obtuse angle. These angles are going to be acute. We also have two equal sides and a third side that is different. We also have the obtuse scaling triangle, where again we have three different angles, 1, 2, and 3, and we have three different side lengths, 1, 2, and 3. Keeping in mind that one of our angles is obtuse, it's greater than 90 degrees. All right, another one is a right isosceles triangle, a three-sided, three-angled shape with two equal acute angles. That would be at this leg and hypotenuse and this leg and hypotenuse. We have two equal sides and we have a right angle. And a right scaling triangle, a three-sided, three-angled shape with two acute angles, kind of like our 30, 60, 90, so 30, 60, and 90 degrees, and three different side lengths, 1, 2, and 3. All right, after that, you need to sketch out the transgression of quadrilaterals from a basic generic four-sided, four-angled figure, which we call a quadrilateral, to more detailed types of quadrilaterals, beginning with the kite. The kite has two pairs of adjacent congruent sides, shown in red and blue, two opposite congruent angles, which are shown by the arc marks, and that is what we call a kite. If you go off on the other direction with parallel lines, the first figure is called a trapezoid, or they call it a trapezium in the UK, where a trapezoid has one set of parallel lines. That's the only condition. From the kite morphs into a rhombus, because we're not talking about parallel sides, but we do have 4 congruent sides, and we have 2 pairs of opposite congruent angles. So these angles are congruent and these angles are congruent. And by virtue that the rhombus also comes from the parallelogram, we do have parallel lines. So that's the kind of the relationship between the kite and the parallelogram. When you put the 2 set of characteristics together, you get a rhombus. Well, from the trapezoid, a parallelogram also comes from the trapezoid, because instead of 1 set of parallel lines, now we have 2 sets of parallel lines. When we do that, we have 2 pairs of opposite angles. So again, these are congruent, and these 2, which are opposite each other, are congruent also. From the trapezoid again, we also have what is called the isosceles trapezoid. Again, it has 1 set of parallel lines, but you can draw it to where 2 sides are congruent, or at least we have 1 pair of sides congruent, and we have adjacent angles are congruent. So the red arc marks here represent congruent angles, and the blue arc marks here represent the other set of congruent angles. So let's go back to the parallelogram. The parallelogram goes off in 2 different directions. Either we can continue with parallel lines, or we can start changing the angles into 90-degree angles. So we've already talked about the rhombus. If you notice the transformation of the parallelogram to the rhombus, we have 4 congruent sides and 2 pairs of opposite congruent angles. So that comes from here. Here the parallelogram has 2 sets of different sides. Here the sides are all the same. Or we can go ahead and change our parallelogram into 4 90-degree angles, which now creates a rectangle. And that also happens with the isosceles trapezoid. If you make the set of parallel lines congruent to each other, then you end up with 2 sets of parallel lines and 90-degree angles, and it forms a rectangle. Now, when you combine the rhombus and the rectangle's characteristics, this is where we get our last figure, which is a square. So it kind of combines everything all together. We have 2 sets of parallel lines. We have 4 congruent sides, just like the rectangle, or just like the rhombus. But like the rectangle, we have 4 90-degree angles. So this is, again, the transformation of a basic quadrilateral all the way to the most specific type of quadrilateral, which is a square. So it would be helpful to write this down in your journal. It's a really great graph to refer back to as you continue in geometry. All right, and then to continue our review, we have regular polygons, which are all equilateral sides and all equal angles, and these are ones that you are probably familiar with. Our basic triangle is really called an equilateral triangle. Our regular polygon, or our regular quadrilateral, is actually called a square. And then from there we go to the different types of polygons. So a five-sided polygon is a pentagon. Then we have our hexagon, heptagon for 6 and 7, octagon for 8, nonagon for 9, decagon for 10, and it goes on forever. You can Google all the different names of all the different polygons for all the different number of sides. It's quite interesting how long the names get. But keep it in mind that even though we have regular polygons, we also have irregular polygons, which means it doesn't matter how many angles or what the angles are or what the side lengths are. We still, any 3-sided, 3-angled polygon is a triangle, or we have the quadrilateral when it's not a square, or we have a pentagon. Even though this doesn't look like a pentagon, it has 5 sides and 5 angles, so this is truly a pentagon. Hexagon, heptagon, octagon, nonagon, and decagon. And again, you can draw any of these any way you like. These are just samples, but as long as it's got 10 sides and 10 angles, it is a decagon. All right, done with the review. So let's go ahead and do example 1. Go ahead and try to complete this on your own. Remember to use any appropriate math symbols and geometry terminology in your description. Make sure you label all the vertices, right angles, and measurements. And continue the video when you are finished. All right, if you are done with example 1, here are the possible steps. First, you might want to draw AB, line segment AB first. You would align the set square so that one leg aligns with AB and place the ruler against the other leg of the set square. Mark a point X however many centimeters away from AB. Draw a parallel line through AB, or a parallel line to AB through X. Realign the set square with AB, situate the ruler so that it passes through A, and draw line segment AD with the line segment length of whatever you decide. Now line segment AD is drawn perpendicular to line segment AB. Mark the intersection of the line through A and the parallel line to line segment AB as D. Repeat the steps to determine what C is. All right, let's try example 2. Complete example 2 similar to example 1. Remember to use appropriate math symbols and geometry terminology in your description. Make sure you label all the vertices, right angles, and measurements. Continue the video when you are finished. Right, you should be done with example 2. So, use what you know about drawing parallel lines with a set square to draw the rectangle ABCD with AB equaling 3 centimeters and BC equaling 5 centimeters. So, using our set square again, we would draw AB as 3 centimeters, and then using our set square and our ruler, we would make sure that we have a 90-degree angle and mark off 5 centimeters. And then again, you can't just finish this up on your own. You have to use your set square to make the parallel lines in either order, whether you do CD first and then AB or vice versa. So when we have our rectangle, the quadrilateral ABCD with the line segments AC and BD would also be called the diagonals of the quadrilateral. And they should be congruent also. All right, example 3. Go ahead and complete example 3. Remember to use appropriate math symbols and geometry terminology in your description. Make sure you label all the vertices, right angles, and measurements, and continue the video when you are finished. All right, you should be done with example 3. So, here are the steps. We are drawing a parallelogram. The steps to draw the figure, we want to do PQ first. So we have 5 centimeters of P and Q. Then we align the set square and the ruler so that the leg of the set square aligns with PQ, and we mark an X, 4 centimeters from PQ. So you could do that right here. Or a point if you want to. Well, it is a point, and you can label it X. They don't include the X right here, but you could label this point right here X. Then using your set square, you would draw another line sliding along that, and that is going to be parallel, so we can call that line is not going to be defined yet. But now what happens is you go back to PQ using your protractor and measure 130 degrees from Q. That's going to help you draw, once you mark that, that's going to help you draw your line, and you can do an arc mark. That's going to help you draw your line from R to Q. And then wherever it passes, line segment RS, that's going to be the one side of your parallelogram. Then from here, if you wish to do that, you can use your, because these are going to be parallel, use your set square and your ruler to go ahead and draw your SP. Now you don't even really have to measure that this is 50 degrees because, again, since these are angles on a line, 130 and 50 is going to make 180 degrees. All right, let's do exercise 1. Remember to use the appropriate math symbols and geometry terminology in your description, and make sure you label all vertices, right angles, and measurements. Continue the video when you're finished. All right, you should be done with exercise 1. So this one is a little tougher because notice how we have to, these parallel lines really don't match up with each other. But again, if you have lines drawn that are longer than this, you might have to go back and erase them, but that's okay because you can make the lines longer as long as the distance between D and E is 3 centimeters. Then once you figure out, after doing 140 degrees and 40 degrees, this is going to end up being 3 centimeters, even though it's kind of far away from our original 3 centimeters. All right, example 4. Go ahead and complete example 4, and when you are done, continue the video. All right, you should be done with example 4. So using a set square and the ruler, you're doing the same thing, a parallelogram with a side length of 5 centimeters. You can draw a point, or you can go ahead and mark your angle first at either the 80-degree angle or the 100-degree angle, and then go ahead and make, since these are going to be the same, then this has to be 5 centimeters this length. So you might have to play around with your length here for AD or BC, but you should end up with a rhombus with all equal sides. All right, so let's wrap this up. Why are set squares useful in drawing parallelograms? Well, they give us a means to draw parallel lines for the sides of the parallelograms. A protractor, ruler, and set square are necessary tools to construct a parallelogram. A set square is a tool that gives a means to draw parallel lines for the sides of the parallelogram. All right, we'll see you in class.